words. Okay. So who has questions?
I have a question. Is there an
Sorry,
answer
just
key
one
for the
second. My
practice?
speakers don't seem to be working. Ah, uh-oh. Give me one second. I'm gonna go get headphones. Ah, okay, I should be able to hear now. Sorry. What was the question?
Is there an answer key for the practice exam that was linked on the syllabus?
No, there's not, unfortunately. Would you consider, okay, question is, would you consider J plus equals 7 to be an expression? I know it's a statement, but I'm not sure if it's an expression. And would access modifiers be considered part of a method header? Okay, so J plus equals 7. I'm going to pull up a whiteboard. So the question was whether or not, well, the first question was whether or not J plus equals 7 would be considered an expression or a statement. I would lean towards the um, idea that this is an expression, or sorry, a statement. Um, because if you ask the question of, well, what does this evaluate to? It doesn't really evaluate to something. It computes a value, but then immediately stores it back in another value. Um, and so if I asked you, what is the type of this, you'd be kind of hard pressed to answer. So I would say that that's a statement. As for the second question, access modifiers be considered part of a method header? They would be. So um, access modifiers in the sense of public, static, void, foo, into X, into Y. Um, when we talk about method headers, method signatures, um, the entirety of the header is known as the method header, so that includes the access modifiers. Um, but when we talk about just the method signature, we are just focused on the name and the variables. So the method signature is contained within the method header, um, and the method header consists of everything else associated with the method signature or associated with the method that you're creating. Right. What other questions do people have?
I have a question about one of the questions in the practice exam.
Sure. Let me pull it up. Which question was that?
It was question number 5, the tracing table.
Okay.
So it asks us to trace the table for the call, and when it says tracing table for square and reset, does it want us to use the number 13 for the second tracing table?
Yes. So when this is called, it seeds execution to this square and reset method. Uh, and that value, num13, is just copied into X. So you would basically just run um, this method with X as the double that you're passing in.
Okay, cool.
Could you go over the differences between expression and statements again?
Yeah. Let me reshare the document or a whiteboard. Okay. So the main difference between an expression and a statement, in my opinion, is an expression. you can look at an expression and you can tell me which type or which mathematical type it evaluates to. So evaluates to some value. Um, and a statement is a singular line of code or a singular executable block of code. So some examples of expressions, if I said, or if I pulled up the line int x equals um, y plus z plus 4, where y and z are both integers. The part of the code where you can point at and you can say, well, I know that this evaluates to an integer. If I just printed out this alone, it would give me an actual value. If I tried to print out int x equals y plus z plus 4, the computer would yell at me because that's not valid syntax. So I would say a good litmus test, I guess you could say, for an expression is, can you print it out? So if you have two Booleans, A and B, and then let's say you have a line of code that is Boolean, foo equals A and B. If you print out this line right here, it's going to print either true or false. Um, it is expressing to some Boolean value. And the same for strings and characters and doubles as well. Now, in the case of loops, so if we pull up, let's say we have while x is greater than 7, and then we just out.println hello, and then we have a closing bracket there. In this case, let me highlight the expressions in red. So this would be an expression. It would evaluate to a Boolean, yes or no. In the same sense that this would also be an expression, just x would be an expression. You can print it out. If it's an integer or if it's double, it's an expression. 7 in this case would be considered an expression because it is an integer literal. When you have cases like this where there are multiple expressions contained within another expression, just underline the entire thing. You don't have to underline each individual expression. Hello, in this case, would also be an expression. It is a string expression, you could say. Now, in terms of statements, a statement in this case would be this entire while block. So when you're talking about control statements, so if statements, else statements, if else statements, while loops, for loops, the entire thing is considered a statement because within that statement is everything that's contained, or all of the things contained within these parentheses or these curly braces are relevant to the while loop. So they're contained within this statement. And then in this case, out.println would also be a statement. Okay. Questions on that?
I have one more question. So the method like implementation dot next line, would that be considered an expression or a statement?
Good question. So if you have in.nextLine, I would say this would be an expression because it evaluates to a string, right? Or it evaluates to something that the user inputs. So you could print out in.nextLine and it would print something out. It would evaluate to a string. So I would say that it is a expression. Now string ants equals in.nextLine. This here would be a statement. Where's my box? I can't find a box. Just pretend that this arrow is a box. Oh, geez. Never mind. Okay. Does that answer your question? Oh, there it is.
Yeah, it did.
Okay, cool.
Uh, just one more question. So for design by contract, is there requires an ensures clause like necessary for each method for Java doc?
No, you don't
Okay.
have to include a requires or an ensures clause. They're not required. It's just if you, as the implementer, want to impose certain restrictions on the method. Now, I will say it is best practice if you have a method that's going to be returning something to have the insurers clause be some written statement which tells you what is being returned from that function, which will just help the person who's or the client who's using your code actually understand what the method is supposed to be used for. But say I'm writing a method and I want to make sure that I don't have to deal with negative numbers, I could simply add a requires clause that requires that x is greater than or equal to 0. Um, if, say, you were writing a simple program that would like determine whether or not um, somebody was allowed into a bar, so it was taking in an integer age, you could require that the age is greater than 0 because there are no humans that are greater than 0 years old. Um, that would be an example of something where you would need a requires clause. So it depends on the method that you write.
I have a question.
Okay.
So back on the sample midterm on question 2.2, where it's ask the value of x after the statement, won't the value of x be 0 in this case? Because it's two integers and not a double that's actually being divided.
This question right here.
Yeah.
Yes, that would be just 0. So it would print out 0, 0.0. Because x is still a double, so even if you set it equal to 0, it's going to have that second decimal point.
Uh, so would we get the question wrong if we just wrote down 0 instead of 0.0?
Um, since it's only a point, I would say probably. If it was 2 points, I can see getting half a point off, but it's a double instead of an integer, so it is 0.0.
Cool. And that would count as a statement, correct? Because because something you can print out technically or have the value of.
This entire thing would be a statement. Yes, double x equals 1 divided by 2. The expression in this case would be 1 divided by 2.
Cool, thank you.
Mhm. Is there a key to the sample midterm? No, there's not, unfortunately. But if you would like to, the lecture that I posted, we went through pretty much, I think, every question on this exam um, in the lecture that was posted on the YouTube playlist from Tuesday. So if you want to skip over the 10 minutes of RSS that we did, um, and then just go to the well, I guess we did everything but this, which we can do now. If nobody else if nobody has any other questions, we can do this now. Could you explain question 2.1 about the magic number? Yes. Um, so, 2.1 magic number. Okay, when Checkstyle warns you about a magic number in your code, what does this mean? Explain briefly why this warning is something you, as a software professional, should pay attention to and consider fixing, even if you decide to change your code or to remove the warning as a mere class assignment. So magic numbers in the code are any integer or double, I believe, literal that exists within the code. So if you remember, integer and double literals are just actual integers that show up within the code. So integers that aren't tied to a specific variable or aren't tied to a specific constant. And the reason that this is bad is because um, in most cases, I'll give a different answer than I gave on Tuesday. In most cases, uh, numbers or integer literals in your code are meant to represent something. So let's just take this for example. In this case, the integer literal 2.0 or 3.0 is representative of a multiplicative factor that we want to apply to the random number. So instead of simply hard coding in the value, it might be better programming practice to store it in a constant. And the reason that we would do this is because oftentimes when you write code, you're not going to be the only one to use it or read it. So if you write a section of code that has a bunch of magic numbers which have some meaning, but only exist meaningfully to you. And then you hand that code to me, and I read your code. All of a sudden, I could probably infer what 3.0 is in here. I could probably infer that you're trying to um, multiply a 0 through 1 number to 3.0, but it makes it a lot easier on the programmer to do so. So that's an answer of why you would want to fix magic numbers in your code. Another reason is to have single point of control over your code. So if you have a number that comes up often, instead of hard coding it in with integer literals, you could set it equal to a variable. And that way, if you ever need to go back and change that value, you can just update it in the constant and it will propagate throughout the code. Okay, question 6 from the sample exam. Okay, so this is the body of main, so it prompts the user for a password candidate, and until either the password candidate is the empty string or the password candidate is acceptable according to is okay. Okay, so how do I write on the screen? Okay, I'm just gonna open it up in a whiteboard. Okay, so you have to read in a bunch of inputs from the user until I'm gonna put it on my second screen. Can you still see that? Somebody unmute and just tell me if you can still see that.
No.
No, it went away. Okay, awesome. Um, is it back now?
No, this is just a whiteboard.
Yeah, that's what I was asking. Can you see the whiteboard?
Yeah, we can see the whiteboard.
Oh, okay, cool. Okay. So we start with a simple reader in equals new simple reader 1L. And I don't think there's any way to make the text smaller. Okay. And then we start with a simple writer out equals new simple writer 1L. Okay. And then the first thing we should do is we should ask the user for a password. So I'm going to say out.print, please enter a password. And then I'm going to store that password in a string called password candidate equals in.nextLine. So now we have a password stored in string candidate, and we want to loop while this password is not the empty string, and while it is also not okay. So we're gonna have a while loop here, and we're gonna say while password candidate dot length is not equal to 0. So that takes care of our first condition. And then we're going to say, well, that is the case, and the password candidate is not okay. So is okay password candidate. And the reason that we're doing and in this case is because only one of these conditions has to be true. So if we pass in the empty string, what's going to happen is it's going to get to here, and it's going to say password.length equals 0, because the length of the password is 0, and it won't even go into the while loop. If we pass that through short circuit evaluation, and then we test the is okay, if that comes back true, then this will evaluate to false, and we will break out anyways. So while that is the case, we want to say to the user, to a print line, invalid candidate, try again, and then we can just print out again, out.print. Please enter a password. And then the same process. And then because we already have a string, we can just say that the password candidate is equal to in.nextLine. Should the length in this case be length? I believe so. I think I'm going to double check. Length of string in Java. Yeah, you have to include parentheses afterwards. Okay, so it would be this password character dot length. Cool. Okay. Next question we have is to do number 8 on the sample exam, I presume. So let's open that up.
Wait,
Yeah,
on the coding you just did, if we're doing on the test, do we also have to put in like to close the out stream too?
that's already included for you on the sample exam. So you would
Oh,
not,
sorry. Okay, thank you.
yeah, so you don't have to worry about that, which is nice. Okay. Share. Uh, okay. Was it question 8? Question 8. Okay, the following is not a valid XML document. Circle the locations of 3 non-overlapping errors that make it invalid, briefly explaining each error in the space below. Okay, so I believe this is actually a question from it's from the slides. So the first error that I see is that you're opening up a unicorn tag, and then you're opening up a color tag, but then before you close the color tag, you close the unicorn tag, which is illegal code. If you open up a tag, then you must close. It has to be, what's the word I'm looking for? Like palindromic. So when you open up something, it's like opening and closing parentheses. You have to open, or you have to close a unicorn tag, or you have to close the most recently opened tag before you close other tags. So that is the first error that I see. The next one, you have an open youth tag without a closing youth tag. So that's another illegal error. And then finally, this dragon tag should be contained within the pony tag because otherwise you have 2 separate XML trees as opposed to just one. So right now you have one rooted at the pony node and one rooted at the dragon node. So you have to move dragon within the pony tag in order for it to be a singular cohesive XML tree as opposed to 2 separate ones. Okay, any other questions? If not, I can just lock in on number 7.
So for the exam, would we get a question on like, or like, do we have to memorize like all the XML tree methods to use them in a question?
Um,
Or
I
is
would
that,
say you should know what they do, and you should know some of the more important ones. Like it's not going to ask you about iterators over attributes, but you should know, like generally speaking, what dot has attribute means. You should know what label does. So if you call label on a tag versus a content node, you should know what is tag does. I would be surprised if the coding question was about XML trees. So I would say know what they do, but you don't have to memorize every fine detail of them.
okay, that makes sense. Thank you.
Mhm. What else?
Can you go over some of the XML like code like meanings? Not meanings, but like kind of yeah, kind of like meanings.
Yeah, sure. Uh, XML code meetings. Okay. So do you mean the official, like, where are we? Oh, the slides aren't here. Uh, like what is it? Like the what dot label means versus dot tag, like that kind of stuff, or drawing
Yeah,
XML trees. Okay, cool.
just dot label dot tag.
Yeah. Okay, so a lot of them have to do with the difference between, let me pull up a good example of a tree. Um, actually, there's probably one here, or actually in here. A lot of them have to do with the difference between tags and content nodes. If you're able to differentiate between a tag node and a content node and what that means for each one, then you're probably good. The pictures in here. Find a good picture of XML tree. Oh, here we go. Perfect. Okay, so when you think about tag nodes are nodes which can have attributes, nodes which can have children, um, and nodes in which when you call label on them, returns the actual tag that it says it is. So these are contrasted with content nodes, which are always the child of tag nodes, do not have and cannot have attributes, cannot have children, and when you call label on them, print out just whatever the content is contained within that node. And a lot of the methods have to do with checking these uh, properties. So is tag simply returns whether or not it is a tag node. And the way that you can tell it's a tag node is because it's contained within these brackets. So when you're looking at XML as a document, so like an HTML document versus actually looking at an HTML web page, the way that you differentiate between tag nodes and content nodes is that tag nodes will always have these brackets around them, signifying that they're a tag node. Let me see if I can find an example of a content node. Content, on the other hand, is simply just out there in the middle of the XML document. It's not a tag in and of itself. It doesn't have brackets around it, and it's always contained within a tag. So that's how you differentiate between tag nodes and content nodes. Children, of course, of nodes within an XML tree. Tag nodes can have multiple children, so you start indexing at 0 and can go all the way up to not technically infinite, but as many children of an XML node as you want. I think going over question 7 on the practice exam will help a lot because it gives an example of a lot of the kinds of questions that are asked about XML documents. So is it okay if I go over that?
Yeah.
Yes.
Okay, cool. So hopefully you have the exam pulled up. But so we have actually, I'm gonna do this. Hold on. I'm gonna pull up this question in MS Paint and then share that so that I can actually draw the XML tree. Now that'll work better, I think. Okay, screens. Okay, hopefully you guys can see that. Please yell if you cannot. Okay, so when you're going from XML to actually drawing it, I would do so iteratively. So you start with whatever the first line is. The first line is pretty much, well, the first line is going to be this XML version thing, but you never have to worry about that when you're actually drawing XML trees. It's more of just a thing signifying that it's an XML tree. So first thing that we have to actually draw is this Buckeyes tag. I can't really draw a tag on this thing. I guess I could freehand it. So you're drawing XML trees, well, some way to signify that it's a tag. So in this case, you can just draw it like it's done on the slides. And then the content in this case is just going to be Buckeyes. You can include I would include these just in case, just even more signification that it's a tag node. The next thing we see is that we have a self-closing tag, location, which means that it does not have any children. So we can branch off from this root node and see that it's going to lead to a location node. So it'll be the same thing, only this time we have an attribute, and attribute values are always contained underneath the tag within the actual node. So we're going to have a tag here, and then underneath will be the attribute value. So the text in this case will be Buckeyes, or no, sorry, location. And then below that, we will have an attribute key value pair, stadium, which is going to link to home. And there's really not a difference between, say, this right here, where you have stadium going to home, or stadium equals home, or stadium dash home, as long as you're signifying that the key in that case is stadium and it's linking to the value of home. Now, this is XML trees in general. When we talk about XML trees in Java, both the key and the value of this are going to be strings. So keep that in mind. Okay. Next up, we have a game. Looks like also a child of the Buckeyes. So if you have a good way to know which child is of a particular XML node is the level of indentation. So it looks like this game tag is also on the same level of indentation as the location tag. So it's also going to be a child of this Buckeyes tree. So we can branch this off here. Then we can make another tag. Looks like this one is going to have 2 attributes, so maybe I'll make it a little bit larger. Do we have to put the attribute value within quotation marks? I would, just to signify that it's a string. But if you forget, it's not the end of the world. Okay, this is going to be a tag. And then we have text within it, which is game. And then below that, we have 2 attribute values. So we have looks like an op, it's UAB. I'll do arrows. And then we have a date, which is 22/7/2012. Great, and then we can just put that within the tag node of the game tag. It's not the prettiest, but as long as the point is gotten across, the person who's grading it will understand, as the person who's grading it is me. Does it need to say stadium points to home, or can you put stadium equals home? Either one works, as long as you signify to me which direction you know it's going. So if you have an arrow pointing from UAB to op, that would not be correct, because you're saying that the key in that case is UAB pointing to op. Quick question, the midterm will take place in the same room as the lecture. So you just have to show up to class like you normally would, except instead of getting to listen to me yap for 55 minutes, you get to take an exam. I will let you be the judge of which one is worse. Okay, so then we have a child of the game tag here, which it looks like is also a tag. I'm going to run out of room, aren't I? We'll see. Okay, and then it's a forecast tag. So draw the tag here. And again, CS majors, not artists. So as long as it looks like a tag, smells like a tag, it is a tag. Forecast. Forecast. And then below that, it looks like forecast has a content node. So I'm going to draw the smallest of lines right there. And then draw a content node, which looks just like any other node, except it's not going to have this tag that I've drawn, or these poorly drawn tags that I've had around tags, but it's going to say Sunny with 90% probability of football.
All right. Not to cut you off, but so say if we're doing code and it says like dot label, would that print the root node, or
Good
how does
question.
that work?
So if I had some code that said XML tree football equals new XML tree 1, and let's just say that this is stored within a document called football.xml. What this does is it creates an object that represents the root node of the XML tree. So the tree rooted at the Buckeyes tag. So if we called football, or say we had out.println football.tag or .label, in this case, it would print out Buckeyes, because, oh shoot, we're pointing at, this is essentially a pointer, or just an arrow that points to this node specifically. So everything that we run on this will be in association with this Buckeyes node. So out.println football.label would print out Buckeyes. if we printed out football dot is tag, this would print out true because what we're pointing at right now is a tag. If we printed out child 0 dot label, in this case, it would go to the first child. So it would say, hey, go to the football child, go to the first child of that, which is this location tag, and print out the label. In which case would be location.
And for is tag, would you have to do like the football dot child to get the is tag, or can you do like is there a way to like, get like to a specific like uh name?
If you know what the XML tree looks like, the other way to do it would be to like set a new XML tree, like locale equals football.child0, and then print out the label from there. Because what you're doing here is you're saying, hey, locale should be an XML tree that points to the first child of the football tag, which in this case is this location tag. And then you would just be able to run like out.println locale or local.label, which would be location. Or you could print out local.has attribute stadium, which would return true. Does that make sense?
Yes. So, and if you're doing has attribute, you gotta put like say you're doing has attribute stadium, you gotta put stadium in quotes, or can you just put it?
Yes, has to be in quotes because everything's a
Okay.
string. So if you
Okay.
had local, which points to the location tag, dot has attribute, and then you typed in stadium, this would return either true or false. And I believe it's has attribute and not has attribute. Yeah, it wouldn't be has attribute value. I think the attribute value one is local dot attribute value. And then you pass in the name of an attribute, which you know it has, and it would return home in this case. Okay. So that is that part, 7.1. The second one, how many children does the root node of this XML tree have? So when we talk about root node, we're saying whatever the tree is rooted at the first node, which is the Buckeyes node. And in this case, you just have two nodes, the location and then the game tag. So the answer to 7.2 would be 2.
Do we have to draw like the price tags, or as long as we have the angle brackets?
Hmm. I would say draw them just in case. If you have brackets, I probably would just assume that it's a tag. But if it gets into like a situation where you write something like, where's my text? Like sunny with 90% probability, and you include that within tags, then I'm going to assume that you don't know what's a tag and what's not a tag, and you'll get points off. But if you just have these four things in brackets and then this not in brackets, I'm going to assume you know the difference. So I would not take off points. No.
Okay.
What other questions do people have? Right. I will call last call. I'll say going once. Oh wait, sorry. If asked, would leaves be the location, forecast and location tag? If asked, would leaves be forecast and location tag? Leaves in this case would be location and then this tag right here. This content tag right here. There would be two. It would be this tag and then the location tag. Forecast would not be a leaf because it has a child. Okay. Last call for questions. Speak now.
I have a question on one of the test bank uh tests. Am I allowed to show that? Can I share my screen?
Uh, no,
Okay.
because can you just ask what the question is? You're
Yeah.
not you're just it's illegal to like distribute them.
Okay, I thought so. Okay. So it's asking for to complete a method called replace all.
Okay.
The It returns a new string where all occurrences of old character in the string have been replaced with new character, but you can't use the string class replace.
Okay. Can you Slack me like a screen cap of the problem and then I can pull that up. That's not
Uh,
like or actually I have the ODI test bank materials. I can just snip the problem and then pull it up.
okay.
Give me 1 second. Take my email and find it. Okay, I see it. So complete the body of the method, replace all so that it satisfies the contract. Uh, thanks. I will share a whiteboard and we'll take a look at the problem. Okay, uh, so it's private static string replace all, and you want to replace in string str all instances of character old char or old ch with character new ch. Okay. 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 It's a new string where all occurrences of old cards placed in the card. Okay. Here's what I would do. So I would start with a string called ret string, which is just going to store the returning string. And then we have to loop through all occurrences of the string. So we can say, we're gonna have to use char add. So I would say int I equals 0, while I is less than string dot length. And then down before I close it, I plus plus. Okay, so this will take us through every single character in the old string. What we have to do, string indices is char at int, right? So if we want to check string dot char at I, which will give you the current string, equals old char, or the character in which we want to remove. Then we want to append to the return string. We want to have the return string is plus call. Okay, and then if that's not the case, it's ret string plus. Okay, so I will walk through an example because it might not be 100% clear what is going on in the code. So I will walk through an example now of this code. So let's say that we have a string. So we have a string, we have old C, and then we have new C. And let's say that draw boxes for this because this is how this is stored in memory, right? Old C, new C. So that the string that we want to replace is, I'm just going to say it's my name because I'm a narcissist. And the character we want to replace is E. And we want to replace it with an O. Okay, so ret string in this case is going to be set equal to a blank string. So now we have a fourth variable called ret string, which is going to be equal to just a blank string. And this is what's going to hold our answer. So at the moment it's blank, but it's going to hold our answer. Now, we make another variable called I, which is just going to be an indexing variable, but we started out at 0. Cool. So while I is less than string.length, string in this case is Stephen, string.length in this case was 1, 2, 3, 4, 5, 6. So this is the case. So now we check if string.car at I, which in this case, if we were pointing towards it, there we go. Pointing towards it, it's just the character S. So we're saying if the string or the character at I of string equals the old character, so the character we're trying to replace, in this case E, we want to do something. Now, we don't care because this is not true. It's not equal to. So instead, we're going to say the return string should be equal to whatever the return string is plus the old character. A few things I'm seeing here. There should not be quotes around old C in this case because it's a variable. And this should have a bracket around it. Okay, so we're saying now ret string should be equal to ret string plus old character. Oh, wait. Aha, another error. Oh, geez. How are we going to do this one? So it should not be, this is why you test your code, by the way. This was a test. It should not be this. It should just be, why did that not fill? Okay, anyways, we're going to leave it like that. So instead of appending the old car, we're going to append string.car at I, like that. And then, oh gosh, that is ugly. But we're going to deal. And then this should not have quotes either. Okay, so return string is going to equal return string, which is a blank string in this case, plus the character at I. So in this case, return string is just going to be this. Next time around, the same thing's going to happen. We can speed it up a bit. We'll get to the case where it's interesting. ST is going to be the return string, and I at this point will be, hello, why'd you delete? Interesting. Okay, we'll just cross it out. I, in this case, will be 2, I believe. So now when we get here, this is going to point to 0, 1, 2, the E. We're going to get to this if statement right here, and it's going to say the string at the character I equals old char, which it does. So now, instead of appending the current character, we're just going to append the old character, right? So instead of STE, it will be STO. And the process will continue for the other characters as well. So V will have the old character appended, E will have O appended instead, and N will have itself appended. So return string in this case will be stove on. And then finally, I at some point is going to get to 0, 1, 2, 3, 4, 5. I in this case is going to get to 5, which is going to be equal to the length of the string. So it's going to break out of the while loop and then just return string, which is stov on.
Thank you.
Mm-hmm. Yes. Yeah, you would need a semicolon at the end. Right there. So it'd be like that. Okay. Other questions?
And this is also doable for like a for loop, right?
Yes, you could use a for loop.
All right.
Right, going once on any final questions?
Can you go over question 4 on the practice exam?
Yeah. Let me pull it up. This one here?
Yeah.
Okay, yeah, let me do a snipping tool. Right.
Can you also go over the second part of question 4 as well, the explained part?
Yeah. Okay. Oh wait, I gotta reshare. All right, so here's how I would do this problem. I would say that we first want to start with an integer min val, which is going to be equal to initially the first element of the array here. And essentially we want to loop through and find the minimum value. So 4 into I equals 1. I is less than a dot length, I plus plus. And then I believe there's no parentheses around the array length. So you can just do that there, and then open up our bracket. And then all we need to do is check if a sub I, so the current value that we're looking at, is less than min val, then we want to set min val equal to a of I. So each time we go through, we're just looking for a new minimum value. I don't know why it's, there we go. Okay. So we'll check each index location, and if it's less than whatever the minimum value is, put the brackets around here, then we will reset the minimum value to whatever the minimum value should be. And then afterwards, we should have a closing bracket there. And then after we've been through the for loop, we can just return min val. The reason that the precondition is important here is because there is no smallest value of an array of size 0, right? So an array which has no elements has no smallest value. So you need a dot length to be greater than or equal to 1 because an array of length 0 does not have a largest value or smallest value. An array of length 1 does have a smallest value. It's just whatever it is. So yeah, that's why the precondition is important.
Thank you.
All right, last call for questions. I've got like 5 more minutes. All right. There is another review session that is taking place. Gabby is hosting one, I believe, tonight at 8 to 9. So if you come up with any questions between now and then, you can join her office hours. But I will see you guys tomorrow for the exam. Good luck. Make sure you sleep. It's important. All right. Have a good one.
Thank you.
Thank you.